Hi guys, so we are back with our laying the foundation section. And before we start anything, if you are an aeroplane engineer, you need a degree and some education in how the aeroplane works. Like similarly, when you are building microservices, you need some background education, and that is where we are. So 12 factors apps, it's just a design pattern. What is a design pattern? It's very normally present in every aspect of our life. Like we are making a car, making an aeroplane, making a ship, making clothes, producing food. In every one of those aspects of our life, there are some set best practices. In IT, they are called design patterns. Okay. So for making microservices, for migrating microservices, or for making microservices using a greenfield architecture, there are obviously 12 or 13. 12 is very popular. Design patterns or best practices, and we'll talk about it. We have talked about it. This is a recap. So I have included this diagram for you to focus on a simple glance. So first of all, we'll start with Codebase, and then the declare, and every one of those I will describe a little bit detail in the next slide. But this is the diagram where if you put it in your work cubicle or something, you will be able to quickly refer, or these are the best practices. Okay. The 12 factor apps, as I said, is an industry standard architectural model for microservices that follows a number of these 12 steps. Here is something I would like to mention. I would say repeat that you might find your current organization is already following a bunch of those 12 factor apps, right? And in that case, our job is to subtract those practices that are already being followed and then pursue the rest. Say, for example, the first one, Codebase. I don't know anybody who is not putting their code in some kind of a repository. So if you are doing monolithic services but your code is in Git, so your first 12 factor app criteria is ticked, is done, right? So you now have 11. If you have Maven, Gradle, using build tooling, build system, then the second one also is done. So like this. So you need to consider what is the practical number of factors that you need to follow, and you might be already following a lot of those. So next, go to the next one. So the first one, Codebase, keep each microservice in their own repository. No brainer, it's easy. Second, automate environment as well as application dependencies. So what are the environment dependencies? Say you want to deploy your microservices in a Linux VM, and that VM needs Java, and that Java may not come with your microservice itself. That VM needs Java, and that Java installation can be automated through Ansible, Chef. On the other side, if your application has dependencies, say my microservice depends on MySQL, depends on MongoDB, depends on Swagger, for example, I can automate those dependencies using Maven or Gradle. Maven is a little bit older, but still very, very popular. Gradle you can use. So to as and when you need to build a complete package of your microservices, you can just follow Chef and Gradle, Maven or Gradle. So that's the automate environment as well as application dependencies 12 factor, right? Third thing, configuration properties be read from environment like Kubernetes metadata. We'll deal with Kubernetes slightly later in this series. And then so what are the problems of hard-coded configuration? We already talked about earlier in the course, and so this is the third factor. So one of the primary driving factor of the microservice architecture is being loosely coupled, and hard coding configuration properties within our application makes us tightly coupled, makes us go through unnecessary deployment, which is complex. So that is the third criteria, which is easy. And backing services, like if you're accessing a database or a RabbitMQ message queue or a cloud-based message queue, those should be accessible only through an endpoint or an URL. They should not be hard-coded within your application. So they should be coming from your property, and it does not matter whether you are accessing a production URL or a dev URL or a QA URL, your application code should not change, and that should be easy as well. So fifth one is build, release, and run. Separate the build. Number of times what happens, for example, you are building a Docker image, it is taking like 5 minutes, and the run phase should not be clubbed together with the build phase, because the build phase, at the end of the build phase, if you are using Docker, we should have a Docker image. If you are not using Docker, we should have a build jar file or a zip file somewhere uploaded in the shared repository or artifactory or something like that. So the moral of the story is the longer build phase should be separated for the shorter run phase. Why? What is the motivation here? Because so that we can, whenever we need to scale in response to higher traffic, we can scale quickly, right? So that is the motivation behind cutting the build and release phase. So that should be easy as well. Processes should be stateless. So this is a really old, this has nothing to do with microservices. When early 2000, late 90s, early 2000, enterprise Java beans came. One of the most popular enterprise Java beans was the stateless enterprise Java beans. So this is a really well understood pattern across various industry areas, IT industry areas. So this should be really one of the easiest, that your processes should be stateless. Port binding comes free, the next one. Spring Boot has by default 8080, you can configure the port. Node Express by default 3000, you can also configure. So the port binding, your application should be binding to a fixed port and then listening to that port for incoming request. So that should be easy as well. Concurrency scale. The moment you follow a stateless model, right, you set yourself up for easy concurrency. So what is concurrency? Say you have you are using a RabbitMQ queue, and right now there are say 40,000 messages, and you have three or four consumers, which are Spring Boot applications, say. Now, the moment your RabbitMQ message depth, which is goes from 40,000 to 4 million, you should be able to link your cloud provider to the RabbitMQ or cloud provider's queue depth and create more consumers. So that is concurrency, right? That is concurrency is linked to scalability, and the moment you have stateless processes, it is easy to achieve. So that are the first 8, and then let's go to the last 4. So disposability API. So the moment you have stateless, it becomes easy to dispose APIs. And then if you have a fast startup and a graceful shutdown, that's what we need to have. Why do you need to dispose quickly? Because we are deploying to cloud, and cloud VMs are moderate commodity hardware, so they can die anytime. So that is where we need to plan for high disposability. So our when our cloud provider's VM goes away for some reason, maybe electricity or something, some natural disaster, our application should not impact too much, right? Dev prod parity. This is interesting. This is moderate. So what this says, your dev environment configuration should be really close, very close to your production environment configuration. Like if you should not be using Tomcat in your dev and JBoss in your prod, MySQL in your dev and Oracle in your prod. So that's what it says. Why this is important? Because you are preparing your application from very lower environments to go to production. So you're exposing your application to the same environment that you have in production. That is why it is important. 11th one, logs should be streamed and not written to direct file paths. Why? Because as I said, in the cloud environment, the file storage devices are as vulnerable as the VMs. So your application should not be having the knowledge of this is the file path I'm writing to. So because if that goes, then your application also it becomes vulnerable. So Elk and Splunk and PaperTrail are all these services. If you are writing to a stream, just a stream, not a file, all these Elk, Elasticsearch in detail, Splunk or PaperTrail and other log services are capable of taking that from the stream and storing that in their storage, right? So admin, last one, admin processes. If you must say, some people need to log into their production environment using like SSH. If you must do that, you must create a bastion host using within your super secured production environment, and give that access to a very few people. So that's what it says, admin process. If you must SSH into the production environment, do so from a bastion host inside the same protected network. So in this section, what we did, we did a little bit of review of the 12-factor API, and we'll stop here. Let me know if you have any question, and I'll try to help you as soon as possible. As I said, this is a foundation section. Make sure you have complete understanding, clarity of 12-factor before we go forward. Thanks for listening. I will stop here, and I will see you in the next video. Thank you. Bye.